Hello everyone, welcome back. Welcome back to the P101 program. So P1 program. So it's this lecture is called P101.1. Okay. In this lecture, we will deal with the basic unit system. Why do we need units? What is a unit? So if you let's define unit. What is a unit? So if you have something this big, right? And if you have something this big, now how do you know how much larger is this thing? How do you know that? Well, you can disintegrate this stuff into smaller part, right? Small parts. And you can also disintegrate this into smaller parts. Now when you do that, you can find out an equal part on both these sides, and you can add the number, or you can multiply with n and you get the first, and you can multiply the other with m and you get the second stuff, second material. So if m is larger, you know that this is big. If n is larger, you know that this is big. So that's how you compare. You know, units are used for this is the unit. Okay, so unit, the purpose of having a unit is to know which one's bigger. And we also have a standardization, because if you go out and buy like 1 kilogram of something, and the other person is also buying 1 kilogram of the same thing, right? How do you know these are both equal? Well, you can measure it with the weighing balance and you know that it's 1 kilogram. Also, you can measure it this as well. Now you know they are both the same, but how do you know that these are the same, right? How do you know these measuring devices are working in the same way? So for that, we have a system which was developed in the early 19th century. So it's located in France, okay, which is called System Internationale, right? Okay. So in System Internationale, they store everything, right? Like 1 kilogram block of mass, and then there is 1 meter long stick. Okay, I'm just saying this in a basic manner. So that's not exactly how they store it, but we'll get there. But these kind of storing program will enable that we have a measuring standard. We have a standard to which we can measure. You can go there and compare your mass with this 1 kilogram, and you know that they are both the same. Now that's SI, right? Now in SI unit system, there is a system of units. So unit system there is, and that unit system comprises of unit for everything. Like, so you have 7 base units. Okay, 7 base units. You can compare these 7 base units, and these 7 base units form the fundamental basis of everything in our universe, right? You can look at a building and say that the amount of substance in concrete in that building, the amount of people in that building, the amount of light inside that building, amount of current passing through that building, amount of energy in that building. You can use these fundamental units to derive every other unit in the world, and you can measure everything. That's what unit system stands for. Now, the fundamental 7 units. The first unit is mass. So mass is represented in kilogram. So use the unit m, right? And also there is length. Length, which is the second unit. You can use meter for that, and the symbol for that is L, right? And then there is time. You get seconds. You measure time in seconds in SI system, and the symbol is T. Now, three of them have been introduced. Now, the fourth one is electric current, after the great scientist Ampere, right? So you use the same symbol ampere. Okay, you will discuss this in P2 program in more detail. Okay, so there is temperature in Kelvin. Okay, Kelvin. So the symbol is K. You have the amount of substance, which is represented as mole. So you use N for that symbol. And then there is luminous intensity, which is the amount of light in a place, amount of intensity of light. You use candela for that. Okay, candela. So that's our 7 unit system. Okay, so with that aside, right, we have these fundamental units you can use to measure everything in the universe. I'm not kidding when I'm saying that you can measure everything. Now with that units in place, let's do some derived units, right? You can use fundamental units to find some derived units. We are going to derive some more units from the fundamental 7. So we commonly use speed. Speed is equal to distance by time. It's the distance covered in a single second. That's speed of a particle or a material or a car or you. So you can use distance, you have length, and for time you have second, which is t. So you get L times t, which is in the below part denominator, so it's -1, right? And that's the speed, and it is also the same for velocity, because displacement by time is velocity, and that has the same unit. And then there is acceleration, which is quite common. We will use it more, right? Acceleration. Now, if you acceleration, you have distance by time divided by time. It's the velocity, time rate of change of velocity, because it's the instantaneous velocity of a particle, right? Instantaneous velocity of a particle, velocity change of a particle. So that's velocity by time, that's distance by time square, right? So that's L t raised to -2. Okay, so that's acceleration. And then you have area. Oh, you can define area, which is a easy one, right? Area is L squared. You can define volume. You can say in terms of you have 1 liter of something. That means it's a unit, it's a derived unit. So it's L cube, right? That's easy. And then you have something like density, like density. So density has something like mass divided by volume. So mass by volume means m times L minus 3, right? So it's mass divided by volume. We have defined volume, so it's m divided by. So we are deriving the units from derived units. That's very interesting. Now with these unit system, you can do a lot more. If you want, you can go for more things. I give you an exercise. If you want, you can derive units for things that you see. You go out and Google and find things and derive their units. So with that, we can conclude this first part. We can say that we have the basic unit system, and then we have the derived unit system. What we need those unit system. Okay, why do we need them? What do we need it for? We have explained it all, and we will, in the next lecture, I will explain something which is called the mass unit system. Now how it affects, okay, in P101.2, what is a mass, and we'll do an example. We'll do a very good example of how to derive some units, and we will do some problem along with it. Okay, so with this I'm closing it right now. So thank you for watching. Okay.